In our last video, we learned how to add and subtract measurements, and we would write our answer to the least precise place. In multiplying and dividing, we have a different rule. In this rule, we write our answer so that it contains the same number of sig figs as the least number of sig figs in our measurements. So in this one, you have to actually know how to count up sig figs within a measurement. It'll be important to know how to do that. So let's start in with some problems here. Let's take 31.7 units of something times 4.2. And you can always start by doing this on the calculator. And if I did this on the calculator, I'm going to get 133.14. But these are measurements, not numbers. So they have ranges. 31.7 actually means somewhere between 31.6 and 31.8. 4.2 means somewhere between 4.1 and 4.3. So how do I write out my answer? Well, sometimes people get really confused, and if you're thinking about adding and subtracting, you might think, well, both of these went to the tenths place, so maybe my answer should go to the tenths place. But that's adding and subtracting, and this is a different rule because we're multiplying and dividing. In this one, all we have to do is simply add up the sig figs, or find out how many sig figs there are in each measurement. So 31.7, if you Pacific Atlantic it, you'll see that it has 3 sig figs in 31.7. 4.2, of course, only has 2 sig figs. So, how many sig figs should my answer have? And the answer is whichever one of these is the smaller amount. So, we are limited by the 4.2 because it has the smallest amount of sig figs. So our answer can only have also 2 sig figs. So how do I write 133.14 with only 2 sig figs? Well, we start over here on this side, on the left side here, and we know that the 1 will have to be something that we know for sure, and the 3 must be our estimate. So it's our second sig fig. So we only have 2 sig figs. So our answer then is 130. 130. You'll notice the measurement 130 only has 2 sig figs. The 0 is not significant here. We know the 1 for sure, and the 3 is actually an estimate, so that means it's going to be somewhere between 120 and 140. So all you have to do is multiplying and dividing is figure out how many sig figs each of your measurements have, and then figure out what's the smaller number, and your answer needs to have that many sig figs. Let's do another one. Let's take 0.05214, and let's multiply 3.74 by it. If we do this on the calculator, we get 0.1950036. Calculator just crunches numbers. It doesn't understand that you're using measurements, and so we need to be smart and figure this out for us. So how do I write this all the way out, or how far out should I write this? Well, I need to figure out how many sig figs there were in my measurements. This one here, if I Pacific Atlantic this, is present, so I start on the Pacific, and I go this way, and I go to the first non-zero, which is the 5, and I begin counting. 1, 2, 3, 4. So this one has 4 sig figs. This one, Pacific Atlantic, also Pacific, go this way. 1, 2, 3. 3 sig figs in this one. So how many sig figs should my answer have? It should have the smaller number. It should have 3 sig figs. So if I start with the decimal here, this one is going to be significant. This one and this one. There's 3 sig figs. So that's as far as I go. Now if this 0 here were a number bigger than 5, I would have to round that 5 up, but since it's not, I'm just going to write out my answer as 0.195. That's my answer written with 3 sig figs. So it's not about the precise place for this one, it's about how many sig figs there are. Alright, let's do another one. let's take 20.0 times 5. On your calculator, you'd get 100.000, whatever, how far it goes out, maybe. I want to figure out how many sig figs there are in both these measurements. This one here, 20.0, has 3. Those zeros are actually significant. If you Pacific Atlantic it, you'll see that. This one clearly only has 1 sig fig. There's only 1 digit there. That means my answer, final answer, can only have 1 sig fig. And it must clearly be that 1. So my answer here is just 100. That'd be my answer. It only has 1 sig fig. Okay, now let's re-examine this problem. Let's assume that instead of 5, we had 5.0. How's that going to change this? Well, if we have 5.0 now, and this instead of having 1 sig fig has 2 sig figs. So our final answer down here would have to have 2 sig figs. That means the 1 is significant, and then that next 0 is actually significant also. That 0 is our estimate. We estimated it to be 0. Now the next 0 is not significant, but we're going to put it there anyway so that we know that we're holding our place, so we know we're around 100 and something. So this is a problem. How do I, because if I just write down the number 100, a person's going to look at that and they're going to say that only has 1 sig fig. I need a way to show that that 0 is actually significant. And so whenever you get stuck in something like this, when you have to demonstrate that a 0 is significant, we need to write this answer in scientific notation. So 100, we know, is written as, if I just wrote 100, like with 1 sig fig, it's 1 times 10 to the second. But how do I show that? How do I write 100 so that I show 2 sig figs? Well, this number out here in front is the most important thing. This is always, whatever's out here in front of the times 10 is those digits are going to be significant. So the way I would write this, showing 2 sig figs, would be 1.0 times 10 to the second. So you might say, well, there's no difference between 1 times 10 to the second and 1.0 times 10 to the second. Yes, there is. There's a significant difference. This one only has 1 sig fig. This one is a way to write 100 with 2 sig figs. Hope you see the difference there. So sometimes it's tricky. I need to write my zeros as significant. For instance, what happens if I did 5.00 times 20.0? Well, now they both have 3 sig figs. So I still get, on the calculator, I still get 100. But how do I write 100 with 3 sig figs? I need to show both of these zeros being significant. Well, I need to resort to scientific notation. So I would write 1.00. See, that's 3 sig figs times 10 to the 2. So the difference between this one and this one and this one, people might argue there's no difference. They're all 100. But there is a difference in science. This way is 100 written with 1 sig fig. This is 100 written with 2. And this is 100 written with 3. And depending on how the math problem works out, I'd have to choose which one of those is going to be correct. So it's kind of tricky, but your rule for multiplying and dividing, and so I did all these multiplying, but if I did them all dividing, it'd all be the exact same rule. I need to figure out how many sig figs there are on each measurement, and whatever the smallest number is, that's how many sig figs I need to use in my final answer. Hope that makes sense for you.